Okay, so I want to show you how to sketch the graph of r equals 2 cosine 3 theta. And probably the key is that you can try to manipulate this equation, but it isn't easily written in terms of x and y. So what we're left with, so you can play around and you can try to multiply and all of that. What we are left with is essentially trying to sketch. So you see here it says sketch the graph. Now, here's how we start off. I'm going to record the relationship between r and theta. Now here's how does r depend on theta? Here's the question is, how does r depend on theta? Well, the answer is, well, r is going to be twice cosine of 3 theta. So I'm going to graph r versus theta here. Now, what is 2 cosine 3 theta? First, I know the amplitude is going to be 2, so I may as well just put in negative 2 to 2. And because I've got cosine of 3 theta, I know that this curve is going to be 3 times as fast. So 3 times as fast as if I had just cosine of theta, right? So if cosine of theta typically starts up top and down, then back up, and then here. So 1 period is usually 2 pi, right? So this would be for cosine of theta. Cosine of 3 theta is going to do all of that action of starting at the top, going to 0, going to the bottom, going to 0, coming back up to the top. It's going to do all of that in a third of the time. So at 2 pi over 3, it will have gone to the top, gone to the bottom, come to the back, and be at the top. Do you see that? You get the idea? That's why I'm saying it's 3 times as faster. And another way to see that it's 3 times as faster is 3 times as fast. 3 times as faster. Another way to see that it's 3 times as fast is to take the derivative, right? So if you take the derivative with respect to theta, you'll get a value that is 3 times the derivative of 2 cosine theta, right? So because of the chain rule, that tells me that my theta is moving 3 times as fast. Okay, so if we put this in, then it looks like at 2 pi over 3, so at 2 pi over 3, we will have gone down to 0, down to negative 2, back to 0, and then be out at 2, and then down to 0, right? It's going to keep on going like that. Okay, and it's going to repeat. So now what I do is I'm looking over here. I'm looking at the relationship between r and theta, and my pen is going to be moving along my graph here. Okay, so let's see how this works. So now, let me use a different color here. Okay, so when theta is 0, r is 2. So that means that I'm going to start out, because theta equals 0. Do you see how theta equals 0 is along here? Okay, so when theta equals 0, I'm going to start out at 2. That's where I'm starting out. And now what happens to r as theta increases, r is decreasing and coming back into 0. Now when is r going to hit 0? Well, let's see here. Let me actually, what does it mean for r to be at 0? So if you're starting out here, now as theta increases, right, which means we're going around here, as theta increases, I don't stay at 2 for r. My r is getting smaller. So if I end up at 0, that means I'm back at the pole. So do you see how I did that? So theta is increasing, but my r is decreasing. So theta is increasing, so I'm moving counterclockwise, but my r is decreasing. So I should be moving counterclockwise and towards the pole. That's how I end up here. So I've got to see, when do I come back to the pole? Well, now let's see. If this is 2 pi over 3, now 2 pi over 3, and I need to divide that by 4. So this is going to be, what is this, 2 pi over 6? Wait, half of 2 pi over 3 is going to be pi over 3. So this will be pi over 3. Okay, and then this will be pi over 6. And then this will be, what is that? Pi over 3 plus pi over 6, which will be, so pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Got it, got it, got it. 0 pi over 6. Okay, so pi over 6, pi over 3, pi over 2, and 2 pi over 3. So I just needed to figure out these important points. And I'm going to update my polar plane to indicate the special values of theta. So for me, what are the values of theta that are important, right? In this instance, it's not really about pi over 4, pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 0. What's important is 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, and so forth and so on. So let's see here. What is 2 pi over 3? That means that's about 2 pi over 3. How many degrees is that? 2 pi over 3 times pi should be 180 degrees. So that is what, 360 over 3? So that is 120 degrees. Okay, I got it. So it's like a little bit over here. So let me actually just modify. Okay, so we don't really care about this and this. We can leave that, that's fine. But I'm going to say here what's important is pi 120 degrees, which I'm going to estimate is like here. Okay, so what I want to do really is I want to take my, so 120 and then 240. What's 240? 240 is like right here. So I'm trying to take, do you see what's going on here? And now this, which is, so this is 2 pi over 3. This is 4 pi over 3. Now I need to take 2 pi over 3 and split it into 4. So 2 pi over 3, 4 pi over 3. Split the 2 pi over 3 into 4. So this is half of it, which is going to be pi over 3. Okay. And then half of that is going to be pi over 6. Okay, and then, yeah, that pi over 2 is going to show up. Okay, so we get an idea here. Now, with my little marker here, I'm going to indicate the path or the trajectory of my particle. So the particle is going to start out 2 units. I kind of think of the pole as home base, right? So I start out 2 units away from home base, and then I'm coming in towards home. Okay, and I've got to be at home within pi over 6. So pi over 6, I'm here. Now let's do the next phase, which is from pi over 6 to pi over 3. What's happening here? I am leaving home base, but remember my r is negative. So leaving home base, so this is pi over 6 to pi over 3. I should be leaving home base, going back out to 2, but because it's negative, I need to flip it. Okay, so so let me actually do this a little more carefully. So instead of going out like this, I'm going to flip and I am going to be going from here to here. So notice that I stop as usual at my little r equals 2. Okay, and then I'm going to do something very similar, which is I'm coming back in, but then I'm going to flip it. Right, so it should be, so I'm going to end up, I'm going to kind of hurry this up because we're taking a while. So I end up coming in like this. Now I'm back home, okay, to home base here. And then I go out again. So at this point, I should be at pi over 2, which is here. And from pi over 2 to 2 pi over 3, I should go back out to 2. So it should go out here to 2. Okay, and now all of this repeats. And so the repeating action is just going to give me essentially these, I'm going to have these little petals. So I'm just going to kind of keep looping out and out and out and right. Okay, and here's something to note. As we do this, notice that our curve never extends past r equals 2. And that makes sense because our r values are never going to be larger than 2, right? Because cosine is always in between 1 and negative 1. So r should never be, so r is going to be in between 2 and negative 2. Okay? All right. And now what I want to do is show you kind of on Desmos, what are we doing here? Okay, yeah, so this is kind of looking at what's happening here. Pretty. It's got 3 little petals. It's beautiful. But what's more interesting is if you go to settings, and now for the grid, you actually can choose between Cartesian or polar. Okay, and now as we look in with the polar grid, the curve makes more sense because it's actually following, right? It makes more sense. The boundaries and the limits of the curve make more sense when you look at it in terms of polar coordinates, because you see how the r and the theta are impacting each other. Okay? All right, so practice these because I love to put in a question like this on the exam.